Let us calculate the moment of inertia of a disk about an axis of rotation which is passing through the center of disk and it is perpendicular to the plane of disk. As disk is a rigid body, we cannot directly calculate its moment of inertia. We first need to consider an element, and by integration of moment of inertia of elements of ring over the given range, we'll find the moment of inertia of disk. Here, for a disk, we can consider small elemental rings which are of radius x and width dx, like this. So if we consider such elemental rings which are of radius x and having width dx, several such rings when integrated from center to the circumference of disk, we can say we'll be able to get the whole disk. For this element, if say its mass is dm, we can write the mass of element as mass of elemental ring is, this can be written as mass per unit area multiplied by the area occupied by this ring. So the total mass of disk is m and its radius is r. Here we can say its mass per unit area is m by pi r square. We multiplied with the area occupied by the disk, which can be given as its length into the width, that can be written as 2 pi x dx. As we can see, we cut the ring and flatten it, its length will be 2 pi x and the width can be taken as dx. So in this situation, the mass of this element will write as m by r square into 2x dx. Now if it is a ring, as we can see this is a ring, the moment of inertia of the elemental ring can be given as di, which can be written as dmx square. So in this situation, as we have just now studied moment of inertia of a ring, we can write as mr square. So for a ring having mass dm and radius x, moment of inertia can be written as dmx square. This we can write as, just we substitute the value of dm over here, it will be 2m by r square multiplied by x cube dx. Now total moment of inertia of a whole disk can be given by integration of all such elements, which is integration of di, and we can write it integration of 2m by r square into x cube dx, and we substitute the limits of integration from 0 to r. Now here mass and radius of the disk can be taken as constant. Here only variable is x. So integration of x cube can be taken as directly x 4 by 4 and we put the limits from 0 to r. Here we can see we'll get it 2m by r square into r 4 by 4 minus 0. So here this 2 gets cancelled out and r square gets cancelled out. We'll get the moment of inertia of disk to be half mr square. This is the standard result for moment of inertia of a disk about an axis of rotation which is passing through its center and perpendicular to the plane of disk.